Chapter 10, How to Design Effective Tables. When to use tables. Before proceeding to the how-to of tables, let us first examine the question of whether to. As a rule, do not construct a table unless repetitive data must be presented. There are two reasons for this general rule. First, it is simply not good science to regurgitate realms of data just because you have them in your laboratory notebooks. Only samples and breakpoints need be given. Second, the cost of publishing tables can be high compared with that of text. And all of us involved with the generation and publication of scientific literature should worry about the cost. If you may or need to present only a few determinations, give the data in the text. Tables should not only give standard conditions without variables and data. Table 16.1 is faulty because two of the columns give standard conditions, not variables and not data. Suppose temperature is a variable in the experiments. It can have its column. If all experiments were done at the same temperature, however, this single bit of information should be noted in the materials and methods section and perhaps at the footnote to the table, but not in the column in the table. The data presented in the table can be given in the text itself in a form that is readily comprehensible to the reader without taking up space with the table. Very simply, these results would read: aeration of the growth media was essential for the growth of Streptomyces collicolor. At room temperature 24 centigrade degree, no growth was evident in stationary cultures, whereas substantial growth occurred in shaken culture. Table 16.2 has no columns of identical readings, and it looks like a good table. But is it? The independent variable column, temperature, looks reasonable enough, but the dependent variable column, growth, has a suspicious number of zeros. You should question any table with a large number of zeros, whatever the unit of measurement, or a large number of 100s when percentages are used. Table 16.2 is a useless table because all it tells us is that the oak seedlings grew at temperatures between 20 and 40 centigrade degree. No measurable growth occurred at temperatures below 20 centigrade degree or above 40 centigrade degree. in addition to zeros and 100s. Be suspicious of plus and minus signs. Table 16.3 is of a type that often appears in print, although it is obviously not very informative. All this table tells us is that as the gracious, as the color, as the every corner, and as the rainbow wing sky grew under aerobic conditions, whereas as the no color and as the granicus required anaerobic conditions. Whenever a table or columns within a table can be readily put into words, do it. Some authors believe that all numerical data must be put in a table. Table 16.4 is a sad example. It gets sadder when we know at the end of the footnote that the results were not statistically significant anywhere. P is equal to 0.21. If this data were worth publishing, which seems doubtful, one sentence in the results would have done the job. The difference between the failure rates, 14%, 5 of 35 for Norcelin, and 26%, 9 of 34 for potassium penicillin V was not significant. P is equal to 0.21. In presenting numbers, give only significant figures. Non-significant figures may mislead the reader by creating a false sense of precision. They also make comparison of the data more difficult. Unessential data, such as laboratory numbers, results of simple calculations, and columns that show no significant variations, should be omitted. Another very common but often useless table is the word list. Such a list might be suitable for a slide in a presentation, but it does not belong in a scientific paper. Table 16.5 is an example. This information could easily be presented in a text. A good copy editor will kill this kind of table and incorporate the data into the text. Yet, when copy editors do so, and this leads to the next rule about tables, they often find that much or all of the information was already in the text. Thus, the rule, present the data in a text, or in a table, or in a figure. Never present the same data in more than one way. Of course, selected data can be singled out for discussion in the text. Tables 16.1 to 16.5 provide typical examples of the kinds of materials that should not be. Now, let us look at material that should be tabulated.